Alrighty, guys, ladies and gents, welcome to the newest episode of the F.O.C podcast. As always, sponsored by Northstar Technologies. I'm your host, Kyle McLaughlin, and today we have a really exciting episode. It's the final part of our three-part series for Northstar A-Z. So today's episode is really technical, which is great for you industry pros. So if you're an engineer, if you're an architect, if you're a construction pro, general contractor, project manager, developer, investor, I think this episode is for you because we will be going over the very technical benefits of why our composite materials, FRP, are superior in nature and easier to use, more feasible for a lot of these projects, especially large scale projects, than our competition, whether that's steel, wood, or concrete, or anything else under the sun. For those of you that can see me on our social media platforms, you'll notice that I'm wearing my Falcons shirt. A little personal touch. I am a big Atlanta Falcons fan. We had a massive win last night against the Tampa Bay Buccaneers in overtime, 36-30. So if any of you guys are Falcons fans, rise up. If you are Bucs fans, I'm sorry, but still love you guys. Anyways, let's get on with the show. So, part 3, I'm going to pull up my little slideshows here so you guys can all see it. We're starting with the comparative analysis portion of this. So just a little recap. Last time I showed you guys more or less the market benefits and the different markets that we're in, our expedited build times. I showed you a little bit about our Owens Corning relationship as a strategic partner and a major investor in our company, which is amazing. But now I'm going to get into the nuts and bolts as we close out this series and talk about the comparative analysis. So what does that mean? It really means how do we compare against traditional materials, right? So we are a advanced building system. We are different than wood. We're very different than steel. We're very different than concrete, which are your three major, more mainstream, if you will, or widely accepted building systems that are currently used in the market, and also they're adopted into the code. So when we came up with this technology, right, the wall panel, exo shell, and exo frame and exo structure, we actually had to go into code, right, into the ICC code, and become adopted. And we did that through a Florida product approval process, which basically required us to get a tremendous amount of testing, which is what we spent the first few years of this company's lifetime were spent on testing, on product approval, on insurability, on weatherability, on basically how do we back up all the claims that we made. It's all through a lot of testing, a lot of research, and obviously a lot of engineering that goes into our system. So once we were able to get adopted by building code, right, on an international basis, we basically became par, at least from the standpoint of code, to all these different building systems and how code is accepted, how code is interpreted. Obviously, that's up to every specific jurisdiction, if you will. So you have here locally, we have Collier County, we have the city of Naples, we have Lee County, we have Fort Myers Beach, we have the city of Cape Coral, Sanibel, Captiva. So just like we have that here locally, all throughout the states, New York City's got its own code review board and architectural review board, LA, and all these different major metro markets, along with the smaller markets as well, that goes through the process of how does this get adopted into code, how is it read, how is it interpreted, and then can or can it not be used in these certain applications, whether it's residential, commercial, industrial, infrastructure, what have you. So back to today's topic. As we're comparing our code requirements, right, and basically everything that's in the code is basically code minimum, right? So if you can check this box, then good, you're in. And what we really try to push, what we're pushing the envelope on, especially with all these major disasters going on right now via hurricanes and tornadoes and just natural disasters, fires, earthquakes, is that we don't just want to be code minimum. We don't want to just check that box, right? We want to exceed it, right? And in this chart, I think does a great job of showing, our material versus steel versus concrete and versus wood in 5 major categories that are often, I don't want to say overlooked, but they're often just set aside, right? And I don't think they have enough emphasis, right? So we talk about corrosion, rot, and resistance to pests, right? Like insects, like termites, mold, all that, right? We talk about the conductivity of the material, right? If there's an electrical storm or a shortage, or lightning strike, or some sort of electrical failure within the building, how does it respond to that, right? The impact resistance which we talked about a lot in previous episodes: ballistic rating, wind rating, tornado rating, the RFI transparency, right? So signals or lack thereof, is it transparent? Is it not? If I'm in this room and it's made out of FRP and I have a Wi-Fi source in here, is somebody 30 feet down the hallway going to be able to experience the same level of bandwidth that I am here in this room, right? And then obviously the fabrication. How is it all built? How is it put together? From raw material all the way through, our process is called pultrusion, and then into assembly and manufacturing here locally at our Bonita Springs plant, and then all the way to the job site, right? So corrosion, where we really stand out is that we resist a broad range of chemicals, and really we're unaffected by moisture or the immersion in water, right? We resist insect damage. Like I said earlier, termites, they don't need composites. They only like wood or organics. Painting is only suggested when exposed to UV. So obviously our system, especially as a finished system, can be painted, but it doesn't have to be, right? Because there is that UV resistancy, right? So now I'm going to compare the other three: steel, concrete, and wood. Steel, on the corrosion side, is subject to oxidation. Corrosion requires painting or galvanizing, right, to make it rust-proof for many different applications. For concrete, it's subject to wear and tear, right? It's brittle. It can absorb water. It can break down under stress. It's penetrable by mold, by certain pests. I've seen animals chip away at concrete. I've obviously seen structures collapse due to earthquakes or other calamities. So all that is important to consider, especially being a porous system. Concrete is going to absorb a lot of water if it's exposed. And if you do have steel rebar within your concrete members, then obviously that is going to spall all the way into the rebar and then make that expand and rust and then compromise that concrete structure, right? And then wood, we all know about wood. It has warping, it can rot, it can decay, especially if it's not pressure treated or treated for a certain use. Wood can be very beautiful to work with. Carpentry, I think, is a great skill. It's a great trade to use. So I'm definitely not knocking wood, but in the sense of a structural system, right? When you're building, walls for a house or flooring for a house or a roof for a house, I think there are better options, right? When you're using wood in a non-load bearing capacity, like interior framing, skilled carpentry, cabinetry, all that, I think that's a great use for wood. And obviously you're going to get that beautiful look as well. So just to clarify, it's not that I'm knocking on any of these systems. I just think that case use application is really, really important and often overlooked when it comes to these capacities, right? So back to wood, we said it could warp, we said it could rot, we said it could decay, especially when exposed to moisture, to water, and to other chemicals, and also susceptible to attacks by insects such as termites, borers, and ants, and all sorts of different pests that can obviously compromise wood, including mold. Mold being a big problem in some storm-susceptible areas such as Southwest Florida, Florida in general, and some other coastal regions as well. So that's on the corrosion side. Now, we talked about electrical conductivity. So FRP, composites, are non-conductive, right? So they're high dielectric capability, meaning that they're not going to conduct electricity and they're not going to amplify that electrical current, right? They're actually going to minimize it. Whereas steel, again, we all know metal is a high conductor, and it has a grounding potential, which can be dangerous, for people, right? As that current can literally go through you. Concrete, moist concrete combined with steel components, aka rebar, can conduct electricity, which is something important to know. Can also be susceptible to fire in an electrical storm. Same thing with wood, right? Definitely conductive when it's wet, and if it does face a electrical strike, again, very susceptible to fire. Impact resistance. So back to the FRP on how we compare that. We do not permanently deform under impact. The FRP, depending on its makeup, especially when it's a glass fiber reinforced polymer, we can do carbon, we can do basalt, we can do all sorts of different main cursors, but especially when it comes to glass, right? It does have like that ductility and flexibility. Think of it like a fishing rod. When you're fishing and it pulls and it bends, right? It always goes back to its original shape. Whereas if it was made of, let's just say an aluminum base member, then once it bends, it's permanently stuck that way, right? Unless you physically bend it back. So that's just, it's an example we like to use just to show how fiberglass is used in a very, not relevant, right, to building structures, but at least in a very comparable, easy to understand example. Glass mat is in pultruded parts, distributes the impact of the load to prevent surface damage, aka my fishing rod example. And even so in sub-zero temperatures, so even when it's really, really cold, right, or even really, really hot, there is no compromise to the structural system, as opposed to other materials, such as steel. Can permanently deform under impact, like I mentioned earlier. Concrete is brittle, so it can break, it can crack, especially during settling or even on high-speed impact. And then wood can permanently deform or break under impact, right? Again, what is that load-bearing capacity? What is that impact-bearing capacity as compared to concrete, as compared to wood, as compared to steel when it comes to FRP, especially when you're choosing what material you should go to based on site-specific location conditions. Again, Florida is a great example because we're what's called a HVHZ, which stands for High Velocity Hurricane Zone. So all these impact, wind, load pressures are very, very important uplift when it comes to our specific region, right? Moving on to RFI transparency and EMI too. So we are a transparent system. And again, this is project specific, what I'm about to say. So if you find yourself in a situation where you do not want to be radio frequency or at all transparent, then we have members and we have additional material that we can add to our base wall to make it more of a concealed, non-bandwidth penetrable enclosure. So this is good for like a safe room. It's good for, maybe for DoD if you're doing a SCIF, or if you're doing a data room that needs to be private and you don't want those radio frequency or Wi-Fi frequencies to be able to leave your enclosure, then we can adhere to that. But for the sake of this example, we're talking about the transparency values and benefits to it, right? So transparent to radio waves, EMI, RFI transmissions, used for radar and antenna enclosures and supports, right? Steel is a big interferer. It's a big disruptor of Wi-Fi and radio frequencies. So is concrete because it can dampen it, right? It's not as bad as steel, but definitely dampen it. And you can test all this when you go into, like, let's just say a predominantly metal building like a warehouse. You'll notice that even if you look at your phone and you look at the amount of bars that you have for service, it'll drop significantly once you enter a structure made of steel or even concrete for that matter, right? And wood is the only one that I think is comparable here on this example. It is transparent. That's why modular construction with wood is very popular when it comes to needing radio and Wi-Fi frequency transparency, right? Because wood is also transparent. And then the last point being fabrication. So our advantage is that we can be field fabricated using simple carpenter's tools, okay? The only thing that you can't really do with our system, especially on the exterior side, is because we're using that 1/4-inch ballistic plate. It's ballistic for a reason, so you can't really nail into it, right? If you take a nail and a hammer, it'll just bounce right off. You're not really gonna penetrate that. You can drill it with a diamond bit, so that piece of our structure, if you will, especially if you're using exoshell for a load-bearing wall or non-load-bearing, we have a guide manual, if you will, for field work on that. But anything else, such as our studs, the framing, the trusses, the decking, all that can be simply field adjusted using those simple carpenter's tools. You don't need any torches. We're not welding anything. And because it is lighter weight, it allows for easier transport, easier assembly, easier logistical capabilities, right? We can load on a truck. We will dimension out of a flatbed truck before we weigh out of it, if that makes sense to you guys. So meaning that we can stack much more than a traditional material, but those dimensions are going to come into play, especially for DOT requirements when it comes to transporting things on the highway. But we will never weigh out because we're that much lighter than our competition, okay? For steel, in the same comparison, it often requires welding, cutting torches, heavier materials, and special equipment to erect and install. Obviously, that poses logistical challenges as well. Concrete, very, very heavy, requires specialized heavy machinery for equipment, with a very labor-intensive process to create concrete, to pour slabs, footers, tie beams. All that is very labor-intensive and very complex. It's not something that really is like a one-man job, right? Wood, again, here's an advantage for wood too. It can be field fabricated using simple carpenter's tools, right? It's just wood. You can nail into it, you can drill into it, you can saw it, you can do just about anything with wood. Okay. Moving on here to the next slide, I'm going to go over a few comparisons with you guys. The first one is going to be time savings. And then we're going to talk about FRP versus concrete, FRP versus steel, a little bit about our stress endurance and our maintenance and energy savings, and then we're going to wrap it up with some financial and maintenance savings as well. Okay, so let's get into it. So from a time saving standpoint, we have, for those of you that can't see, that you're not watching on our social media at Northstar TGI, you won't be able to see the screen, but I can describe it pretty well. It's essentially a side-by-side comparison on a graph standpoint of FRP versus precast concrete, right? From a production timeline based in days. So FRP on an average, this is for your average commercial building, right? All these studies and examples and market analysis and comparables are based on a commercial building. And I'll go over that here in a little bit. But essentially for FRP production, we're right at that 40-day mark, whereas precast concrete is a little bit over that 50-day mark, so we're saving about 10 days there. But really where we shine is the installation, right? Installation can be done as little as 5 days, or for precast concrete, at least in this example, you're looking at a few weeks, right? And this is just a note here, but according to a recent study, the cost maintenance and repairs for a precast concrete platform was approximately $55 more per square foot over the course of 15 years than a bridge composed of FRP. So that's important to know, because $55 a square feet across many square feet on a bridge is a significant maintenance cost, right? So FRP demonstrates its value by significantly saving time in the construction project, which subsequently leads to substantial cost savings. When you compare that to precast concrete, FRP's production time is 15 days shorter, like I mentioned earlier, and then that results in 15 weeks of saved labor cost, and obviously on the installation process inside as well, reducing your labor and the equipment necessary to install FRP versus concrete, okay? And here's just some quick bullet points about FRP versus concrete, being that it's stronger and more flexible than concrete, therefore it's more resistant to impact and natural disasters. FRP weighs about 8 times less than reinforced concrete, okay? So if you take 1 square foot of FRP, or cubic foot of FRP, if you will, for volume measurement, we're weighing in at about 7 pounds. If you take that same measurement for concrete, they're closer to that 60 to 70 pound weight. So that is a huge difference for installation and a huge difference for logistics as well. Concrete is porous, it absorbs water, leading to the formation of rust in the steel reinforcements and the deterioration of the concrete surface, right? FRP products have a service life of approximately 100 years, and this is just what we tested to. Honestly, it can go beyond 100 years. Quick example, if you think about oil rigs out in the Pacific or in the Gulf, there's a lot of FRP incorporated into the oil rigs, and that is probably one of the most harshest environments that you can think on planet Earth, right? You have salt water, you have tidal exposure on waves, you have storms out there, you have heat out there. I mean, there's all sorts of, in marine life obviously, all sorts of different variables that are quote unquote attacking, if you will, the material, and they're still out there, right? With very little structural degradation. So that's important to know. They require virtually no maintenance throughout that time frame, and on the other hand, a comparable reinforced concrete, especially a surface, is going to start to degrade really within that 15-year mark or sooner, depending again on the case use of that material for that specific exposure, right? And then from a cost-saving standpoint, FRP materials enable faster and more cost-effective installation compared to the labor and time of concrete, right? FRP is low maintenance, like we talked about, and it uses the advantage of having reduced weight for logistical savings. Okay, we're going to move on to FRP versus steel. So just a couple quick notes about FRP versus steel. We are pound for pound stronger than steel. So if you've seen, I did a recent reel on Instagram and Facebook where I showed how much lighter FRP is than steel. So I actually took, I think it was probably a 15-foot I-beam lengthwise, and I was able to pick it up and more or less do like some rows with it, which was kind of funny. It got a lot of likes on Instagram, which is cool. But for the purpose of what we're talking about here on a technical basis, if that was steel, there's no way. I mean, I would challenge even some very, very strong people, and by no means am I a weightlifter or a very strong person. I consider myself pretty average when in that department. Yeah, I wouldn't be able to do that, right, if it was steel, or nobody else could. So really, really interesting when you start thinking about installation, logistics, and how the weight reduction incorporates some benefits and values into that, right? FRP, being that it weighs 70% less and that it's stronger pound for pound, it also gives us a stronger strength to weight ratio, which is about 4 times that of steel. Okay, so we're pound for pound stronger, we're 75% lighter, and on a strength to weight ratio, we're actually stronger 4 times. And sometimes more. The beauty about our material is because there's so much engineering in the fabrication itself. If there's a specific case use for needing more load tolerance or more reinforcement, right? The way that we orientate our glass fiber, or especially with GFRP, glass fiber reinforced polymer, depending on that orientation of the glass, we can actually make certain load-bearing properties stronger than we would if we didn't orient them in certain ways. So just to give you an example, if you have a large span, let's just say in a house you have a living room that has 12 sliders, and that's a huge opening, right? And you have a beautiful beach view, if you will, or a bay, whatever. Normally you'd have to pour a very, very thick tie beam to be able to encompass for that rough opening. Well, with our FRP, whether it's a truss that we're creating or we're using I-beams or whatever the member is, for that specific use, we can actually orientate the glass fibers differently to create a stronger, more capable load-bearing member than just infinitely pouring a thicker tie beam. And obviously with more tie beam material, with more concrete, comes more cost. So again, just a little bit of the engineering advantages there. And to the point of steel, though, FRP often costs less than steel with installation equipment and labor savings. It's pretty significant. Another quick note, which is interesting too, steel corrosion actually has a huge impact on the economy and the environment, more than you'd even think. But according to a study done by NACE International, the cost of corrosion globally, get ready, is $2.5 trillion with a T, $2.5 trillion. That is the cost of corrosion globally. That is a significant amount of money. That is just a naturally occurring degradation that happens to steel. $2.5 trillion, that's significant. So definitely a market that we would excel in. A little bit about stress endurance, right? So again, comparing concrete and wood and steel. Again, for those of you that are not watching this on our social media platforms at Northstar TGI, you would see a graph here of stress versus strain, right? And where the higher the stress on members like steel, for example, the strain creates those permanent bends, right? Same thing with concrete and wood, they actually break. So FRP materials have inherent flexibility and elasticity. When subjected to stress, they deform slightly without suffering damage. This flexibility allows them to distribute and absorb stresses efficiently. So in contrast, concrete and steel are more rigid and can experience sudden fractures or deformations when subjected to excessive stress, leading to strain and failure, right? There's also the element of fatigue resistance, in which our materials are more fatigue resistant, that they can withstand repeated loading and unloading cycles. Think about movement, think about seismic activity, right? Without experiencing structural degradation. In contrast, again, traditional materials, especially steel, can suffer from fatigue and fatigue failure over time when exposed to cyclic loading. This fatigue resistance is vital for structures subjected to dynamic loads. Again, seismic would be a good example of that. If you're in California or you're anywhere in the western seaboard, you're subjected obviously to a seismic activity, to earthquakes. So this would be a good point to note. And then we also have damping properties. So our materials are engineered to have an excellent damping properties, meaning that they can absorb and dissipate energy from external forces such as vibrations, impacts, and again, seismic events. This ability to dissipate energy helps reduce the strain on material and increases its longevity. And just a fun fact, FRP composite building materials have a greater flexural strength than timber. And then as we start rounding this up, I'm going to talk a little bit about financial savings and energy savings and maintenance savings. So really when you start looking at a project or at a building or an investment, if you will, holistically, you think about that cost of ownership, right? And what is that cost of ownership on an asset that you own over a long period of time? Let's just say anything over 3-5 years, and obviously into a few decades, depending on, again, the case use. Maintenance and energy savings are really going to be a big factor for that cost of ownership, right? So, interesting fact, 44% of a commercial building's energy consumption is attributed to HVAC systems, right? Especially down here in Florida or in areas that are hot and require cooling. And obviously we have our mechanical components to do that, such as an AC unit. That's 44%, basically half of your energy consumption, even in your house, is attributed to AC. So, wouldn't it make more sense to have more energy efficient enclosures? That way it reduces the load on your AC, makes it last longer, but obviously reduces that energy bill. That's just one little feature here that we're talking about. FRP composite building materials notably reduce thermal conductivity. That is when heat from the outside penetrates into the interior. That's conducting energy, which is obviously thermal loading. There's an absence of that obviously with FRP because we do not thermal mass or thermal transfer, right? And obviously in conjunction with our strategic partners, Owens Corning, and using their installation, we enhance the efficiency in Northstar structures, Northstar homes, Northstar commercial buildings, so on and so forth. This not only prolongs the life of the actual unit, but also boosts the performance of its mechanical components, such as an HVAC system. Not only that, but it also results in substantial maintenance savings for the owner himself, right? Or even the tenants, right? Everybody benefits from considerable energy savings in a comfortable indoor environment, shielded from external climate variations. And then last but not least is the financial savings. Structural FRP provides savings in the following areas, right? I'm just going to rattle through these and I'll touch on a few. Labor, which we talked about a lot, right? Think about lifting this material, moving it around, installing it. It's much easier to do that. We can do a couple thousand square feet a day with a 5-man crew, for a commercial residential structure, which would be very challenging to do with other materials, right? Equipment necessary for installation. Again, so a lot of systems need a full-blown crane. In many cases, all we need is a lull or sometimes just some manpower, right? Transportation and logistics, we talked about that. We're maneuverable, we're light. We will dimension out before we weigh out when it comes to DOT transportation. So we're definitely facilitating a smoother transportation and logistic process. The installation, because we're prefab, right? Either we can be prefabricated as far as the wall panels go and then just flatbed them over to a job site, or we can be fully modular where we're actually sending full pieces or enclosures of a room or an opening as a modular system. Same thing with curtain walls too. And those can be erected in days as opposed to weeks or months with other materials, right? Operational costs is a big savings too. FRP structures save on energy costs, provide ideal indoor conditions, and incur minimal post-disaster repair expenses. Right, we talked a little bit about that on the previous slide. Along with maintenance, because we have an exceptional energy efficiency, it significantly reduces long-term maintenance costs because we need very little maintenance, right? And there is a life cycle component to it too. Our shell is going to be significantly extended when compared to a traditional structure from a lifetime standpoint, especially when exposed to corrosion and any other stressors environmentally or not, right? Materials, obviously the cost saving from an example standpoint, concrete structures with GFRP, which is glass, fiber reinforced rebar, which we do carry as well. So it's not just the structural systems from the standpoint of a building and enclosure, it's also structural systems, as a reinforcement, such as rebar. It often requires less concrete cover and no expensive additives for rust prevention, which is important. And then if you ever want to decommission an FRP structure, there's a lot of cost savings there due to their ease of removal and the ability to recycle and repurpose the material into other uses or within the same life cycle of FRP itself, making the process more efficient and environmentally friendly. And then obviously that all wraps up into cumulative maintenance savings over the lifetime of a, let's just say, office building for this example, right? The annual maintenance cost for an office building in the US is between $1.60 all the way to $2.80 a square foot, depending on the building's use, right? This includes scheduled maintenance to keep systems in working order, preventative maintenance to upkeep systems before they break down, and then actual repairs for the building's structural systems. Again, this is only amplified when you're in areas that are more susceptible to natural damage. And then we show a little example here again for those of you that can't see my screen. On a steel structure and on a total maintenance expense on a 15-year cycle, steel on average is about $420,000 for maintenance over a 15-year cycle. Now this is based on a 10,000 square foot commercial building in the US. It's just an average. It was a study that was done public. Whereas for an FRP structure, it is literally half that. It is $210K over that same 15-year timeline, right? And a lot of that has nothing to do with structural degradation, okay? So that's it, guys. That is Northstar from A to Z, from a standpoint of going through our markets, our case uses, how we came to be, what our highest and best uses are, and then of course the value proposition to the homeowner, the building owner, to whoever the developer or whoever's actually using the structure, right? Even if it's a tenant, there's significant advantage for everybody involved. And I thank you for listening to all that. I know that if you're not necessarily an industry pro, it could seem a little overwhelming with all the technical jargon. And trust me, it's taken me a little bit to learn it as well. I do not have an engineering background, but it's really fascinating to learn about these structures and about alternative and more advanced ways of building when you're exposed to it on a daily basis, right? Especially being a Florida native and having experienced, I want to say, almost 10 hurricanes now in my lifetime, and personally seeing the destruction, being affected by it personally, especially with Ian, and now seeing all the calamity and catastrophe in North Carolina and Tennessee and the northern areas of Florida and some of the Tampa areas, it's just really sad to see. And I know that there's a better way that we can do this, and there's a lot of great companies out there. There's a lot of great minds. It's not just Northstar. I mean, obviously I want to be self-serving and say that we can solve the problem, but really it's going to take all of us. It's not just one man's job or one company's job. It's going to take a collective approach to really investing some time and some brain power and obviously some financial resources to solve the problem of natural catastrophe happens. It wipes out a city or an area or a structure, and then what? We use financing or resources to just build it back the same way that it was before. Almost like callously expecting that it's not going to happen again, right? But it's unfortunate because these occurrences are becoming more frequent. Regardless of what you believe in or don't believe in, that's pretty much out there. You can see that these things are happening more and more frequently, at least within our lifetime, right? Within our span here on Earth. And we need to be more prepared for it. We need to be more proactive for it. We are, the world's leading technological nation when it comes to entrepreneurship, when it comes to manufacturing, when it comes to tech. So we should be the leader in facilitating new structures for people to live in and for people to operate out of, and for our military and for everybody that really has a reason to use it. So that's my spiel on that. And again, thank you for joining me on this episode of the F.O.C. podcast, sponsored by Northstar Technologies. I'm your host, Kyle McLaughlin. Our lines are open. Our emails are always being read. Our website is active. We're very active on social media as well, and our handle is Northstar TGI. You can find us just about anywhere. That stands for Northstar Technologies Group Incorporated. Please reach out to me. Please reach out to our sales team, our administrators. Everybody's always really, really happy to talk about the good work that we're doing down here. And again, it's going to take a village. It's going to take all of us. So we encourage your feedback. We encourage your thoughts, your comments. Love to hear from you guys, and look forward to the next episode. Thank you.